Let's practice simplifying algebraic expressions together. So in these first set of 6 problems, we're going to go ahead and combine some like terms. We're going to go ahead and make sure that we underline terms with x. So I'm going to go ahead and just draw an underline. I'm going to use this green color. And then we're also going to be double underlining terms with y. I'll use a double underline with a blue here. And we're going to put a box around constant terms. Now keep in mind, constant terms are just going to be normal numbers without any variables. So we're going to put boxes around things that are constant terms. All right, so let's get right into it. For number 1, we have 3x plus 5x. So these are two terms. They both have x in them, so we can go ahead and combine these, right? So 3x plus 5x we can combine to make 8x. This would be the simplified version for this expression. All right, let's check out number 2. For number 2, we have 4y plus 5 plus y. So a couple quick things we want to take note of. First of all, we have 3 terms. The first term is this 4y. We also have this 1y over here, so we want to make sure we know there's a 1 in front of this y. And then we have a constant term of 5. So let's go ahead and put a box around that because we know that is a constant, that term we know the value of. So if we go ahead and combine like terms here, the 4y plus the 1y is going to make a total of 5y. And then the 5 as the constant term is just going to be a 5. We can't do anything with that. So here we have a coefficient of 5, but we also have a constant of 5. So the 5s are doing different things here, different parts of the expression. For number 3, let's see what we got going on here. We have a 5x. We're going to single underline that. Do we have any other x's? We do have 1x over here. I'm just going to go ahead and put the 1 in for the coefficient. These are both 1x. We can go ahead and combine those in just a moment. I'm also going to go ahead and double underline this term with a y. We have these two different variable terms, the ones with x's, the one with y's. If we add the 5x and the 1x, we're going to get a total of 6x. And then if we go ahead and add the 4y and the 7y, that's going to be 11y. So this right here would be our most simplified version of this algebraic expression. All right, next, let's see. We have some addition signs, but we also have some subtraction. We have one subtraction sign over here, so we have to be careful with this one, right? Let's see. I will go ahead and single underline all our x terms. So this is 2x and 4x. Those are going to combine right away to make 6x. Let's go ahead and just do that right away while we're here. And then be careful with the constants, right? You could write, instead of 2x minus 5, you could write 2x plus negative 5. So what you can do here is you can actually just think about this minus sign in front of it as a negative, because if you just turn it into an addition problem, it would be a negative 5, right? So we have these two constant terms here, and we can combine these. So whether you want to think about it as negative 5 plus 13, or you want to think about it as a 13 minus 5, either way, you're going to be getting 8. So I think it's good to look at it either way. I like 13 minus 5, a little easier though. And so we're going to go ahead and write plus 8. This would be as simplified as you could write this. All right. Number 5, we like this plus sign, that's good. This minus sign, we're going to want to turn this into plus a negative 3y. And then this plus sign is fine, but then this minus sign, we're going to write plus a negative 5x. All right, so let's go ahead and start with our x terms. So we have 6x, and we have this minus 5x. Keep in mind, that's going to be a negative 5x. So if you combine those, 6 minus 5 is going to be 1. So I'm going to go ahead and say we have 1x here. Up to you if you want to write that 1, but I think it's helpful to see. Next, we have these y terms. We have 7y, it's double underline. This is a negative 3y, so make sure we keep track of that negative in front of this 3y. But 7y minus 3y, or 7y plus negative 3y, is going to be a positive 4y. Okay? And then finally, we do have a constant term here. Our constant term here is just going to be 8. All right, so we can go ahead and just write plus 8. We can't do anything with that. So our final expression here is just 1x plus 4y plus 8. Okay, up to you if you want to write this 1 here in our answer, but putting it doesn't hurt. Okay. For number 6, keep in mind that we do have a negative 4x here. We have a positive 6 here. We have a positive 7x here. This 3 here is technically a negative 3 if you add a negative 3 instead of subtracting a positive 3. Again, you can turn all subtraction into addition. And then we like this plus 2y here. So the plus signs are a little bit easier to deal with. So we have a negative 4x and we have a positive 7x. So up to you. You can do negative 4 plus 7 or 7 minus 4. 7 minus 4, if you take away those coefficients, that's going to be 3x. Now what about any y terms? Well, over here I see 2y, but I don't see anything else that's a like term with it, so I don't think we can do anything. We'll just write plus 2y. And then we got some constant terms here. This 6 is just a positive 6, but keep in mind this 3, this is a minus 3, so you could rewrite it as plus negative 3. So keep track of that minus sign in front of it. So 6 minus that 3 is going to be a positive 3. So this would be as simplified as you could write this expression. All right, let's check out 7 through 12, where we're going to go ahead and kind of do the same thing here, just we're going to have some fractions instead. So some of our coefficients are going to be fractions, and some of our constants may be fractions as well. So let's see, for number 7, let's see, we are going to underline, kind of similar here, we're going to single underline where we have terms with x, and double underline terms we have y, and we're still going to box our constant terms. So just make sure we're following the same directions and reading those, okay? And so let's see here, we have x terms here. I'm going to go ahead and single underline this one and single underline this one. And I'm going to put a box around this term in the middle, this 5. Okay, so the 5 can't be combined with anything, but the 2/3 x plus 4/3 x, we can go ahead and add their coefficients. So I'm going to write this 2/3 plus the 4/3. That's going to be equal to 6/3. But 6/3 simplifies down to just being 2, or 2 over 1, right? So we can combine those to say that's going to be 2x. And then the 5 didn't have any other constants to combine with, so this would be the most simplified expression. Okay. For number 8, let's see, we have this 5/4 y, that's a y term. We have another term with y, so those are like terms with each other. And then we have two constant terms. We have a 4, and we have this negative 3, technically, if you rewrite it as 7/4 y plus a negative 3, if you add the opposite, right? So let's see, if we combine the y terms, we have 5/4 for a coefficient, and we have 7/4 for a coefficient. Those will combine to make 12/4 for the coefficient, and 12/4 is 3. So our coefficient here is going to be 3 for the y when we combine those. And then if you combine the 4 and then the minus 3, or 4 plus negative 3, whichever way you want to think about it, that's going to be 1. So that would be our most simplified expression. For number 9, we have x terms again. So x terms, we're going to single underline 7/8 x, and this is a minus 3/8 x, or a negative 3/8 x. So keep in mind the minus is important. And so we really have 7/8 as a coefficient, and then minus 3/8 as the next coefficient. If you do that, you're going to get 4/8, and if you simplify that, you're going to get 1/2. Okay, so the coefficient for the x terms is going to be 1/2, so we have 1/2 x. And then for our constant terms here, we have a positive 9, and then we have a negative 5, so make sure we have that negative in there. And then 9 minus 5 is going to be a positive 4, so we can write plus 4. This would be our most simplified expression. All right, for number 10, looks like we have some x terms again, so 7/10 x, and then we have a minus 3/10 x, so make sure we have the minus in there. So let's see, 7/10, take away 3/10, that's just going to be 4/10. It's kind of nice, all these fractions have common denominators already, right? And then if you simplify this, you're going to get 2/5. So our coefficient for the x terms are going to be 2/5, or is going to be 2/5, so 2/5 x. And then we have constants here that are fractions, but that's all right. We can deal with that. So 4/9 take away 1/9. So let's see, I'm going to write that on the side here. So 4/9 minus 1/9 is going to be 3/9. And that can be simplified as well. If you divide them both by their GCF of 3, that's going to be 1/3. So our constant term, after you combine like terms here, is just going to be 1/3. All right, cool. That would be our most simplified expression. All right, in this next one, let's see. We have 7/12 x. We have this minus 3/10 x. Ooh, so this is the first time we have uncommon denominators. So that's going to be a little bit more work for us, right? Let's maybe just go ahead and identify some other things. Here's a y term. It's actually kind of nice. It doesn't have any like terms, so we don't have to do any work for that one. And then we have this minus 5x. Keep the minus in there. And then we have this positive 11/6x. So at least these have common denominators. So the x coefficients are the only really annoying part here. All right. So let's see. We have 7/12 minus 3/10. So we have to ask ourselves, when do 12 and 10 meet for the first time? you can go ahead and find out the LCM or the LCD. It's going to be 60. So it's going to be times 5 times 5. So it's going to be 35 over 60 minus, and it's times 6 times 6. So that's going to be 18 over 60. So 35 minus 18 is going to be 17. So we're looking at 17 over 60 for our coefficients. So I'm looking at 17 over 60x. All right, that's going to be our variable term with the x. And then for the y's, keep in mind the y's didn't have any like terms, so that's actually less work for us, so 3/4 y. And then we have constant terms of negative 5/6x and 11/6x. You can do negative 5/6 plus 11/6, or you could do 11/6 minus 5/6, right? So if that's a little easier for you, then just do that. 11 minus 5 is going to be 6, so we have 6 over 6, which is just 1. So it looks like our constant term is just a whole number here of 1. So this would be as simplified as we could go. For number 12, do we have any x terms? Oh yes, we have this 3/8 x, and we have another 3/8 x. So let's see here. We can add those coefficients. So what's 3/8 plus 3/8? 3/8 plus 3/8 is going to be 6/8. And that simplifies down to being 3/4. Always check to see if you can simplify. So our coefficient for the x term is going to be 3/4, so we have 3/4 x. For the y terms, we have this 5/6y minus 1/6y. So let's see, we have 5/6. It's kind of nice they have common denominators, right? So we can go ahead and subtract these. That's going to be 4/6 as our coefficient, but then we can simplify this to 2/3, right? So this would be our coefficient for the y term. So it's going to be plus because it's positive, and it's going to be 2/3 y. Finally, I think we have one more term here that's just going to be this positive 3. So this constant doesn't have any like terms, so we can just write plus 3 here. This would be the most simplified version of this expression. All right, cool. Let's check out number 13 and see if we can apply our understanding a little more to some different types of problems. All right, so for question 13, we're going to be selecting all. So make sure we are picking all the right answers. There could be more than one that are equivalent. Equivalent, keep in mind, just means equal, right, to the given expression. So we're going to provide evidence as well to make sure we are showing some good work here. All right, so let's see. If we take a look at the original expression here, I'm going to use the same colors if that's okay. But let's look at this original expression, half x plus 4.5 plus half x minus this 1/2. So I'm going to just keep doing what we've been doing because I think it'll be a little bit more clear. It'll help me keep organized as well. Let's take a look at the given expression and simplify this first, right? So if we go ahead and combine this half x with half x, half plus a half is a whole, so half plus half is 1x, so I'm just going to write 1x here. And then if you go ahead and take this 4.5 and you take away a half, 4.5 take away half is just going to be 4. So this right here would be what we're looking for. This would be our expression if you went ahead and simplified it, right? So we have 1x plus 4. Notice how our coefficients are not matching as well as our constants are not matching, so this can't be our answer choice. I'm going to cross this one out. Okay. Next, let's see if we look at the second choice. This coefficient matches this one because they both have a 1 in front. Again, you can put the 1 in front if it helps you see it. So this checks out first. However, what can you say? You can say the constant terms don't match here, so this one is not going to be equivalent. All right. For this next one, we have x plus 4. Keep in mind the coefficient for this x is a 1, so you can see here, do the coefficients match? That's a yes, and our constants also match here. So this one is good to go. We know that this is equivalent, right? Just because we can see that the coefficients and constants and everything matches here. For this next one, our coefficients do not match, and our constants also do not match. So this one's automatically not going to be one of our equivalent expressions. Finally here, let's see. This one's a little bit longer. We have to simplify it a bit, it looks like. So 3x minus 2x. What's 3x minus 2x? 3x minus 2x, if you subtract their coefficients, that is going to be 1x, right? And then if you look at our constant terms here, we have this -1, and then we have this +5. So -1 plus 5, or you can think about it as 5 minus 1. 5 minus 1 is going to be 4, +4. So this actually does match what we're looking for. So this one is equivalent to the given expression. So hopefully that was also enough evidence and ways to talk it through. But we want to say we know that here, again, our coefficients match as well as our constants match here. All right, let's check out one final problem. In number 14, we're going to go ahead and identify the error. So there's going to be something wrong that we're going to be looking for here. We're going to see what was wrong when we were trying to simplify this. And then we're going to go ahead and it says provide some mathematical proof and explain, so using words, what error was made and how to correct it. So we have to fix it as well, right? All right, so a student was given the following expression and was instructed to simplify it. So, sorry, I should say simplify. So here's the original expression right over here. Okay, let's see let's follow the steps that they went here. So for step 1, they rearranged the expression to reorganize the like terms next to each other. So let's see, is that what they did? Okay, we have 3x. That's 3x, okay. Plus 7/4 x. Okay, so it looks like they put those ones next to each other. That's true. And then we have 6y. So 6y. I'm going to go ahead and double underline those, right? And then minus 4y. Minus 4y. So they put those ones together. And then they put this, did they put this minus 3 and plus 8 together? They did. And they also put the positive 8 first to kind of make it easier. 8 minus 3 I think is easier to think about than negative 3 plus 8. So I don't know. I think this first one's good, right? I think they did a good job with step 1. I don't see any issues here. Next, what they did, it says they combined like terms. So they combined like terms just for the x's though, right? So they said that's what they did for the x's. So let's see if that's what they did. The x terms are these two over here. So let's see if they did a good job. If they took this, I'm going to use a different color and show it with the x term. So if they took 3/4 x plus the 7/4, you really just have to add their coefficients. Nice, they have common denominator, so that's going to be 10/4. And that simplifies to 5/2. So should the coefficient here be 5/2 for x? I think so. So that one seems good. Okay. Again, we didn't touch this yet. We didn't touch this yet. And we didn't touch this 8 or the minus 3 yet. Okay. So I don't know. This one seems good to me. It doesn't look like they made any mistakes yet. Next, it says they combined y terms. So let's see. For the y terms, that's going to be these blue ones over here. So we have 6y and this minus 4y. So what did they end up getting here? It looks like they ended up getting 10y. So let's see, is that true? Let's double underline to see if this is the case. So if we take this 6y and this minus 4y, what's 6 minus 4? 6 minus 4 is going to be 2. But this coefficient is 10 here. So I think that is the issue, right? I think they must have accidentally maybe ignored this minus sign, and they might have just actually said, oh, they thought it was just 6 plus 4. So I think what this should say here is 5/2 x plus 2y. I think this should be the correct coefficient of 2, and then should it say plus 8 minus 3 here. So I think the issue here we should circle is this 10y over here, right? So in step 3, this is where they made a mistake. It doesn't look like they did anything wrong with these constants. These constants seemed okay here. So I think this 8 and this minus 3 are both okay. I thought the 5/2x was fine. And I think this 2y is supposed to be what the term is supposed to be here. If we look at step 4, it looks like the 5/2, and in step 5, the 5/2x, both of those seem okay. If you look at our coefficient for y, again, these seem like they didn't do anything else wrong here. It just looks like these should be the issue of 2y, right? So I'm going to go ahead and just write this should be 2y next to it. This should be 2y, and this should say 2y. Okay, and then for the constants, I don't think they did a bad job either. I think they did fine combining the constants. 8 minus 3 is just going to be 5. So everything else seems to be okay. Maybe we could also just write it down here that our final expression here should just be 5/2x plus the 2y plus 5. This should be the correct expression at the end. So keep in mind that the directions did say we had to explain what went wrong and how we fixed it. So we can start off by saying that they made a mistake in step 3, as they combined the like terms of 6y and negative 4y incorrectly, thinking that the coefficients were 6 and 4, because that's how they got 10, instead of their actual coefficients of 6 and negative 4. And then finally, by correcting the sign of the 4 and making it a -4, we can get the correct final coefficient for the y term of 2. So that was the only thing that we really had to fix here. So there you have a few different practice problems with practicing combining like terms and simplifying some algebraic expressions along the way. Just keep in mind when you have those plus signs, we're good to go. We like the plus signs. If you ever see a minus sign, you could always rewrite it as an addition problem. If you go ahead and keep, change, flip, or add the opposite, however you want to think about it. But just keep track of those minus signs because they're very important and can mess you up a little bit. If you found the video helpful, please consider giving the video a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing.